Endeavour's onboard radar has now lost lock on the telescope. At that point, Endeavour was just around 85 feet or so from the spacecraft.
Endeavour, since the KU has dropped lock, we've now lost insight into what's going on. We'd appreciate any updates at your convenience.
Okay, everything's looking real good. We're closing at about 0.15, 80 feet or so.
Copy.
And Houston, you can tell Dr. Harley there is a pin on the target on the bottom of the telescope.
Okay, we're going to pass that on.
And Houston, it's really big.
We can't wait to see the video, Sox.
Right now, the bottom of the telescope's about 30 feet from the end of the arm. Closure's real nice, 0.1.
We appreciate the words. Thanks.
There in Houston, the bottom of the telescope's about 20 feet from the inspector. Rates are right about 0.1, maybe a little less.
Copy.
the telescope to the bottom of the, or to the end effector.
Copy. We appreciate the update.
And closures at point 1. And you don't have to respond, Sue. I know you got a lot going on down there. I'll just give you the play-by-play.
And we'll take it.
And Houston, we're just sliding into the end effector camera now. Closures row control, point 1, maybe less.
Copy.
And Houston, the center of the end effector camera is just above the star trackers now, moving real nice and slow, just like in the SES.
Copy.
grapple fixture targets just sliding into the end effector camera.
We copy.
Copy, stabilizing the end effector camera view of the grapple fixture right now, and it's just about stopped.
Copy.
We've got about 15 degrees of pitch misalignment, but we think that's going to be no problem.
We understand.
And cloud's going for the grapple now.
Guidance, Navigation, and Control Officer reports Endeavour's in free drift now. That's a mode where the steering jets are turned off to keep them from interrupting with delicate operations.
Houston, Endeavour has a firm handshake with Mr. Hubble's telescope.
We copy that, Cody, and there are smiles galore down here.
It's quite a sight. We are in drift mode, and Sunpoint is disabled.
We see that, and just for the benefit of the rendezvous folks up there, your prop margins were well within what we predicted. Great work up there, you guys.
Thanks.
Endeavour at present is about 319 nautical miles in altitude above the Pacific Ocean. Just about to move into sunset, several hundred miles off the east coast of Australia.
Endeavour, I'm handing you over to Orbit 2. Just a fantastic job, you guys. We really enjoyed looking over your shoulders on this one.
Hey, Susan, it's a great job to all the rendezvous crowd. Thanks for getting us there in such great fashion. That was fun.
We copy that, and we'll talk to you tomorrow.
This is Mission Control Houston at the point at which the Hubble Space Telescope was captured by the shuttle's robot arm being operated by Claude Nicollier, mission specialist aboard the vehicle. The Orbit 2 team, the lead under lead flight director Milt Heflin, has taken over control of the flight. The capture of the telescope occurred at 2:48 a.m. Central Time as Endeavour moved from southwest to northeast across the South Pacific Ocean on the latter portions of the 30th orbit of the mission.
Endeavour Houston, Orbit 2 is with you. Check your DAP config, Control Excel 1, please.
Yeah, Greg, we jumped ahead a little bit, set up for the maneuver to hover, but we'll put an item 14 plus 1 in.
Okay, Sox, thanks.
And we're also configuring for A9 and Alt 9.
We copy and we're watching. Endeavour Houston, 2 minutes to early handover. Endeavour Houston, disregard the PDI decom. Endeavour Houston, disregard the PDI decom.
Okay, great.
This is Mission Control Houston. The integrated communications officer is powering up the cameras in the payload bay. We have expect that we should have good TV from the orbiter here shortly to see the Hubble Space Telescope on the end of the robot arm.
Endeavour Houston, we have good TV. Looks like camera Delta.
Okay.
First views of the Hubble Space Telescope after 3.5 years since it was deployed in April of 1990. This telescope's 43 feet tall, weighing somewhere around 12 tons. The next step is for Claude Nicollier to maneuver the telescope to the hover position above the flight support system. The flight support system is a circular device in the back of the payload bay that the telescope will be lowered onto. The flight support system also has a camera which is mounted on it, and views from the flight support system can get views of the telescope as well.
Endeavour Houston, the PDI decom fails were the result of the FM system. We have now powered it off.
mission specialist Claude Nicollier is carefully maneuvering the telescope into position above the flight support system. He's using the camera on the flight support system to assist in proper alignment of the telescope above that structure before he lowers it down onto the circular device. The flight support system is a turntable that can rotate and tilt to allow the various work sites on the telescope to always be facing forward to allow the crew members easy access to the various bays and work sites on the telescope. Payload Deployment and Retrieval Systems Officer or Robot Arm Operator here in Mission Control, Al Lee, reports his data shows that the telescope is in the proper hover position above the flight support system. The next step, again, is to power up the television camera on the flight support system. This camera looks directly up at the telescope, and this will help in fine alignment of the spacecraft over the support structure. And Claude Nicollier aboard Endeavour now slowly lowering the telescope down to the berthing position on the flight support system. There are 3 latch mechanisms on the flight support system that will secure the telescope to the structure for the duration of the telescope stay in Endeavour's payload bay for this flight. Endeavour is moving across the Gulf of Mexico on the 31st orbit of the mission. Telescope's now about 3 feet above the flight support structure, the flight support system. Telescope's now about 2 feet above the flight support system. The portion of the telescope that's currently facing the crew compartment is the aft shroud section where the rate sensor units are located, and also the fixed head star trackers. The shiny area directly above the star trackers is the radial location for the wide field planetary camera. The current planning calls for 2 of the 3 rate sensor units to be replaced on tonight's first spacewalk by Story Musgrave and Jeff Hoffman. Each rate sensor unit is comprised of two gyros, and there are 3 rate sensor units. The total complement is 6 gyroscopes. Endeavour is now moving across Florida, just south of the launch site at the Kennedy Space Center, and should shortly be moving from darkness into daylight. The lighting currently supplied by various floodlights in Endeavour's payload bay. Once the telescope is carefully placed on the flight support system and latched properly, there's an electrical umbilical that is remotely operated and attaches to the telescope to supply electrical power to the spacecraft from the orbiter's power. This external power source bypasses the solar arrays on the telescope. Now closing in to within 1 foot of the flight support system. Now less than 6 inches above the flight support system. And as Endeavour moves off the east coast of Florida on the 31st orbit of the mission, Endeavour and the Space Telescope now moving into sunlight.
The engines are about to latch it up.
We're watching.
The Space Telescope's now sitting on the flight support system, and the payload deploy retrieval systems officer reports that the brakes are on the robot arm, so it's now locked in place and holding the telescope steady while the berthing latches are locked in place on the underside of the telescope, securing it to the flight support system. The first berthing latch has been partially closed, and now the crew is moving on to the latch number 3. Two of the berthing latches are partially closed. This one should be completely closed. Payload Officer Jeff Hanley reports that berthing latch 3 is closed completely. The next step is to close the remaining 2 latches completely. Those 2 were initially partially closed. Latch number 2 now fully closed. The last remaining latch is latch number 1. And latch number 1 now has been completely closed. The telescope is secured to the flight support system. The next step is to mate the electrical umbilical to the telescope. standing by to mate the electrical umbilical to the telescope. This is a view from one of the payload bay cameras looking directly up at the telescope at the solar array. This is this solar array is on the right side of the telescope looking back.
That is affirmative.
You are getting the solar array, Greg?
That is affirmative.
Okay.
And the electrical umbilical has been mated to the telescope.
Greg, you can probably see the kink in the plus V2 plus the outboard by stem.
We see that story. We're looking at camera Bravo view here.
with the telescope latched to the flight support system.
The Hubble is latched and the umbilical is mated.
We copy that, Jeff. Great work.
Now that the telescope is latched to the flight support system and the electrical umbilical has been mated, the Space Telescope Operations Control Center folks are continuing with their commanding sequence. The next step is for those folks to transfer the telescope to external power. Claude Nicollier now preparing to release the robot arm from the grapple fixture on the telescope now that it is securely latched and mated to the flight support system. Claude Nicollier now releasing the robot arm from the telescope grapple fixture.
Endeavour Houston, we've got a great elbow view.
This is a view from the robot arm of Endeavour. The elbow camera, which is about halfway down the robot arm, the length of the robot arm. Orbiter is now being maneuvered to an attitude to support battery charging of the telescope's onboard batteries.
Endeavour Houston.
Are you configured for ESC downlink?
It's negative. We can get there if we need to.
Would you like a picture of a bystem?
Absolutely. We'll let you know when we're configured. Endeavour Houston for KT, we are configured. We are ready for the fill pattern for ESC.
You want data rate high or low?
Low.
Okay, coming. Should be getting it.
Okay, we're looking. We have a good fill pattern. We're ready for the image, KT.
This is a view from the end effector camera. We've switched to this camera as routine to do a survey. In view as the grapple fixture that Claude Nicollier attached the arm to on the telescope. The survey that's currently in progress is scheduled to last for about an hour or so as Claude Nicollier moves the arm around to look at all of the various locations on the telescope.
Endeavour Houston, we're seeing something very bright in the end effector camera, if you could check that.
Houston Endeavour, I think I sent 2 frames of ESC. Probably the second one is the only one that's any good.
Okay, KT, we'll look for it.
Claude Nicollier maneuvering the robot arm around to do a survey of the various instruments on the telescope. This is a view of the...
Endeavour, we're ready for external essential bus activation when you're go.
Copy that, Jeff. Stand by on that. We'll give you a go in a couple minutes.
This is a survey of the one of the solar arrays on the telescope, surveying the outboard bistem, as it's called. The solar arrays, when deployed, are deployed similar to window shades, and when they're rolled up in the same manner.
Endeavour Houston for Jeff, you are go for step 2, 2-11.
Okay, we'll press.
Just in front of the telescope, the orbital replacement unit carrier, which houses the various instruments and components that will be replaced, used as replacement parts for the telescope. This telescope, portion of the telescope facing the orbiter's crew compartment at this point is the fixed head star trackers, the aft shroud. This is the location where the rate sensor units are mounted. And just above the star trackers, the axial instrument, or the radial instrument. This is the wide field and planetary camera, and that will be replaced, changed out on one of the EVAs, one of the spacewalks scheduled for this flight. In progress is transfer of the telescope's power to the orbiter's power through the electrical umbilical that was mated to the telescope.
Houston, I guess you saw the external maid bus transfer, and we're showing low amps on PPC number 5. All the others look okay.
We copy, Jeff. We're looking at it. Endeavour Houston, you go for step 4.
Okay.
Endeavour Houston, 2 minutes to handing down to Diego.
The twin solar arrays on the telescope are deployed using two different mechanisms, deploy mechanisms, one called a primary deploy mechanism and a second called a secondary deploy mechanism. The primary deploy mechanism basically folds the arrays down away from the telescope's body, and the secondary deploy mechanisms are the window shade type release mechanisms that roll the solar arrays out. This is a view of the...
Transfer of Hubble to external power is complete. And
We concur, Jeff.
radiation was DPC-5, which we reported.
And as reported by Jeff Hoffman, the Hubble Space Telescope now has been transferred to external power as Claude Nicollier continues a survey of the telescope using the shuttle's robot arm and the end effector camera, the camera mounted on the end of the robot arm.
Endeavour Houston, Jeff, we copied your last good transfer to external power, and we're still looking at DPC-5.
Okay.
Endeavour Houston for Jeff, for your info, DPC-5 has been confirmed failed. It is no impact.
Okay, thanks.
Well, that call is related to one of the direct power converters, and since there are several backups, there's no impact to that at all. While Endeavour has moved out of range of the tracking and data relay satellite system, the orbiter currently is over Diego Garcia, one of the ground sites, so we do still have voice link with the crew aboard Endeavour.
Endeavour Houston, 1 minute to handing back up to Teeters West. Endeavour Houston, we are with you on the west. The control center is going to take a 5-minute break here. We'll be back with you at 0044.
Okay.
It's a view of the location of the wide field and planetary camera as Claude Nicollier continues a survey of the telescope, moving from the aft shroud location at the lower end of the telescope, moving up to the support systems module area. Coming into view, the twin grapple fixtures that are available for grabbing hold of the telescope. Also one of the high gain antennas that's folded up against the spacecraft. Moving to the top of the telescope and the aperture door that is closed, of course, to protect the mirrors. Also near the top of the telescope, the two magnetic sensing systems or magnetometers that will be that new magnetometers will be bolted on top of, scheduled for one of the spacewalks. Moving back down the front part of the telescope. Again, the flight support system that the Hubble Space Telescope is mounted on is a multi-purpose device that can be rotated and tilted to always present the various work sites to the front part of the telescope. Telescope obviously designed for servicing. It has two grapple fixtures available. Also nearly 225 feet of handrails for the crew to use to maneuver about the telescope. The telescope's also configured with 31 sockets that foot restraints can be attached to at the various locations on the telescope.
Endeavour Houston with you on the west.
Okay. Houston Endeavour.
Endeavour Houston, go ahead.
Yeah, we've all been looking at the plus V solar array, and I don't know if you got any downlink or not, but we're ready to give you a verbal description of what we're seeing.
Stand by one. Endeavour Houston, Tom, we are standing by for your verbal, and we're still looking at the ESC downlink. We did not get anything on the east. We did get one or two images on the west when we came up AOS. Those images have not been distributed yet, but we'll be happy to take your verbal.
And do you have downlink now?
Yes, we do. We got a good camera Bravo view.
Okay, then you're seeing what would be the upper outboard bistem on the plus V2 array. There is a definite kink right at the upper edge of the second panel there, as you can see in the max part of the bend. And it looks like, as the bistems, of course, one is inside the other, it looks like the outer bistem has a kink in it, and it is also twisted approximately 90 plus degrees clockwise there at the kink. Then it looks like it all comes back together within a few feet there of the kink. There's also, probably hard for you all to see, we have to look at with binoculars, a second kink a couple of feet below the obvious one that is on the back side there of that section of the bistem. It's not quite as bad, but it does have a little crease in it. The good news is the minus V2 array looks real good. Both blankets down at the compensator rails are centered there. On the plus V2, the lower blanket, the one that is down in our reference, the compensators are centered, but the upper one where the problem is, the inboard compensator is bottomed out in the down direction, and the one that has the kink in it is pretty much centered. Over.
Okay, Tom, we copy all that and we understand. Endeavour Houston, if you folks are done sending ESC photos for the time being, then we can process what you downlinked.
Yeah, it's getting dark. I think we gave you the best we can. There may be some motion in it. We had the camera with the 300 millimeter lens and the 2x extender mounted on a bracket, but they're not really very stable. So we'll be done for now.
Okay, thanks, KT.
This is Mission Control Houston. Endeavour is moving across the northeastern portions of Australia on the last leg of the 31st orbit of the mission. The words came down from mission specialist Tom Akers aboard Endeavour, giving a verbal description of the views that we were seeing of the right-hand solar array, the upper portion of that array where the kink was visible in the outer bistem. Payloads community is off looking at the situation, and we expect that they'll convene a small group to look into that and what the effects of that kink in that outer bistem would mean in terms of rolling the array up in preparation for the change out of the solar arrays that's scheduled for the second of the 5 spacewalks.
Endeavour Houston, reminder, we want free drift.
Endeavour's moving from daylight into darkness as it moves off the upper northeast coast of Australia. The views from the robot arm of Endeavour. The next scheduled steps, at least from the Space Telescope Operations Control Center, is to command heaters on the support systems module and the optical telescope assembly aboard the telescope. This is a view looking back across the tail of the orbiter at the sunset as Endeavour moves away from the coast of Australia.
Endeavour Houston with your prop numbers from the rendezvous.
Go ahead, Houston.
Covey, I thought you'd be interested in knowing just how well you did. You were down approximately 150 pounds at TI. Overall, for the rendezvous, you ended up 11 pounds to the good in the aft, 2 pounds to the good in the forward. For the manual phase, the budget was 288 pounds in the forward, and your actual was 251. For the aft, it was 407 budgeted, and you had 326 actual. Well done.
It's good training. Thanks.
This is a procedure that was sent up to the crew separate from or to be conducted during the survey of the telescope. This is a visual inspection using the end effector camera of the high-gain antennas. Both of the antennas, while they folded up against the telescope as they should have, the latch indications were not received on the ground, and this is just an inspection to verify that the latches in fact did lock onto the high-gain antenna booms as was expected. The indications on the ground were that the latches locked in place as expected, but the micro switch indications did not show that. In any case, the antennas are up against the telescope and in good shape to support the 5 spacewalks scheduled for the mission. Again, this is a procedure that This is a procedure that was sent up to the crew to conduct during the survey of the telescope to ensure that the antenna booms are in the locked position when the antennas were folded up against the telescope.
Endeavour Houston, that's a great view on the high gain. We're ready to take a look at the other side, and go ahead, KT.
Greg, I was trying to do the solar ray displacement observation with the laser, and I am unable to get the data points on the upper parts of the solar rays just because the oblique angle to the window doesn't let me get a return through. We'll try to get the bottom ones in the next terminator crossing on the plus V2, see if we can get you any information.
Okay, we'll take what you can give us.
Again, this is a view to verify that the latches did in fact lock into place when the antennas were folded up against the telescope, and the words from the telescope folks are that they are latched against the telescope, even though the micro switches did not indicate a latch position.
Endeavour Houston for Claude, we need you to move up just a little bit.
Roger.
Endeavour Houston, that's a good arm position, great end effector view. Our preliminary analysis is that the high gain looks like it's fully seated and may be ready to latch. So let's stand by here for a minute and let the payloads folks talk about it.
The preliminary indications are that the antenna did fold up properly against the telescope as expected, but the ready to latch indications were not received on the ground. But the payload community, in looking at this, believes that the antenna is in the proper position and is expecting to try to go ahead and latch the antenna to the side of the telescope. The low gain antenna on the opposite side of the telescope is not visible by the robot arm. The arm can't reach around to the back side of the telescope.
Endeavour Houston, we are configuring to send the commands to close the -V3 high gain latch. we'll give you a 30-second advance call.
Roger, Houston.
Currently in work is a command sequence to send to the telescope to this forward-facing high-gain antenna. This view from the end effector of the robot arm aboard Endeavour gives the payload community a feeling that the antenna is actually in the proper position, even though the microswitch indication did not show a ready-to-latch indication when the antennas were folded up against the telescope earlier before capture.
Endeavour Houston, 30 seconds to motion on the high gain minus V3 latch.
And the commands are being sent now to close the latch on the minus V3 high gain antenna. There are two high gain antennas on the telescope, 180 degrees apart.
Endeavour Houston for Claude, if you could move the arm back to the other side so we can look at the other side of the latch. We'd appreciate it.
Okay, he'll do that. And it was kind of cloudy down in Houston this morning.
Well, it was raining when we came in this morning, but no telling how the weather's going to be this weekend. Not that it matters to us any.
Endeavour, we're getting set up to get some more video of the bi-stem. When would you be able to take it?
Jeff, why don't you stand by on that a minute? We want to get this high gain fully latched, so let's get us complete on that, and then we'll advise when we're ready for the bi-stem.
You bet.
Endeavour Houston, for Claude, we'd like you to go down and zoom in if you can so we can get a good view of the latch, please.
Claude says he's going to do that for you.
Thanks.
And Greg, is that the view you want?
That's an excellent view, Claude. Thank you. We're talking about it.
Okay.
Endeavour Houston, Claude, and for the rest of the folks, this high gain looks like it's in adequate position here, that it's adequately captured. The stock is going to look at it, the HST folks are going to look at it some more and do some further analysis, but we think right now that it's probably okay for a reboost. And what we'd like to do now is complete message 18, looking at the other high gain antenna with Bravo and Charlie cameras.
Okay. And you think maybe just one micro switch out of the two is set in the latch position?
Stand by. Story, say again your question, please.
Yeah, since we're seeing transient on the minus V3 latch here, do you think one micro switch is set only?
Story, we had an indication that was evidently transient of a latch at one time. Now we were showing no micro switches there.
Okay.
Crew aboard Endeavour continuing through a procedure to evaluate the latch mechanisms on the high-gain antennas aboard the Hubble Space Telescope. The antennas, as was scheduled, were folded up against the telescope before the capture phase, or the grapple phase. However, when they did fold up, there was not an indication given that they were ready to latch. Those antennas are in a good configuration in terms of all of the spacewalks that are planned. However, if they were not properly latched, that would be an issue in terms of reboosting the telescope or boosting to a higher altitude. So that's what procedure that was uplinked to the crew earlier, to look at the latches and the mechanisms on the high-gain antennas on the telescope. The one forward-facing can be seen quite easily using the end effector camera on the robot arm. The high-gain antenna on the opposite side of the telescope will be viewed using two of the payload bay cameras, pointing those cameras up toward the high-gain antenna and the latch mechanisms. The current thinking is that the antenna on the front of the telescope, the forward-facing antenna in this view, is, while it's not properly latched, is in a fairly good configuration, and the HST folks are off looking at whether that's latched properly enough to support the reboost after all of the spacewalks have been completed. In the meantime, while this is continuing, the survey is continuing of the telescope, the flight crew aboard Endeavour is going through a routine power down of some of the equipment aboard the orbiter that's not necessarily needed or used to help protect all of the consumables margins, that is the electricity usage aboard the orbiter. This is called a Group B power down and is routine on almost all shuttle flights to help conserve electricity. While there's plenty of margin in the consumables at this time, the Group B power down will ensure that we have plenty of hydrogen and oxygen that's used to produce the electricity through the fuel cells of the orbiter. A Group B power down is similar to turning off equipment at home that an individual may not necessarily use, turning off lights in a room that you wouldn't be in. And so the crew is doing that. They'll probably power down one of the inertial measurement units, put it in standby.
Houston, your option, but we can do the Bravo and Charlie survey from the ground if you guys would like to take a break.
Yeah, Greg, we think it's a good idea. We are downlinking B now. I don't know whether you get it.
And we are seeing that. Okay, we'll do it from here then.
Okay. Okay, thanks.
Also powering off one of the onboard cathode ray tubes or the computer screens up on the flight deck. All of this is part of a Group B power down to help conserve the electricity usage aboard the orbiter.
And standing by for your goes for air log resets for the single G2 GPC ops.
Here we go for that now.
Roger.
The view now is of the backside of the telescope, the opposite high-gain antenna, and the cameras used to view the latches on this side will be the corner cameras in the payload bay, cameras B and C. There are 4 corner cameras on the payload bay of the orbiter. These 2 are on the back end of the orbiter near the tail, and those are pointed up directly at the high-gain antenna.
Endeavour Houston, be advised we think the plus V3 high gain is seated better than the minus. We are going to be commanding the latch closed here shortly. We'll give you a 30-second call.
Roger.
The split screen view from the back cameras. The indications are this one is seated properly and will be latched momentarily.
Houston, Endeavour has a firm handshake with Mr. Hubble's telescope.
After 3.5 years of operation, the Hubble Space Telescope has been safely snatched out of orbit by Endeavour's astronauts, capping off a 2-day chase in space to track down and retrieve the observatory. Hubble looks a little worn, but is now ready for 5 days of servicing and repair by 2 teams of spacewalking astronauts. The story of the capture of the Hubble Space Telescope next on Mission Update.
Good morning and welcome to Mission Update. Despite a little wear and tear after 3.5 years in space and almost 20,000 orbits of the Earth spanning 530 million miles, the Hubble Space Telescope is locked down on a work platform in the cargo bay of the Shuttle Endeavour at this hour after European Space Agency astronaut Claude Nicollier used the ship's robot arm to grapple Hubble a little less than 3 hours ago. No one had seen Hubble, of course, since its deployment from the Shuttle Discovery on April 25, 1990. So the first views of the telescope after its retrieval were captivating. One of Hubble's solar arrays showing a twisted or warped effect, as well as a bent bistem. Nicollier maneuvered the robot arm back and forth using the arm's cameras to survey the solar array, as well as other areas of the telescope. Astronaut Tom Akers, who will join Kathy Thornton in the cargo bay Sunday night for the second spacewalk to change out the solar arrays, offered Mission Control a detailed description of the bent array.
There is a definite kink right at the upper edge of the second panel there, as you can see in the max part of the bend. And it looks like, as the bistems, of course, one is inside the other, it looks like the outer bistem has a kink in it, and it is also twisted approximately 90 plus degrees clockwise there at the kink.
But Akers said the other solar array appeared to be in good shape. The arrays are being replaced by new ones because they flutter as the telescope passes in and out of darkness, causing a jittery motion for Hubble's sensitive scientific instruments. Right now, Endeavour, Hubble, and the Shuttle 7 astronauts are sailing about 350 miles above South Africa at the start of their 33rd orbit of this planned 11-day mission. Commander Dick Covey and pilot Ken Bowersox are completing a procedure to shut off some of Endeavour's backup systems to conserve electricity for the remainder of the flight. Endeavour's spacewalkers, Story Musgrave, Jeff Hoffman, Thornton, and Akers, have been taking extensive photos of the Hubble Space Telescope since its retrieval. The astronauts will conduct a review of spacewalking procedures in about 2 hours to set the stage for the first spacewalk later today. The commander of the 1990 shuttle mission in which the Hubble Space Telescope was deployed is now the chairman of NASA's mission management team. Lauren Shriver said today's retrieval of Hubble went according to the script.
It's great that we've gotten back to the telescope now, and it's grappled and berthed on the structure, and we'll be able to start the EVAs tomorrow, it looks like. Everything has worked out the way it was planned.
Shriver said that other than the bent solar array, Hubble appeared to be in excellent condition. Joining us right now from the Mission Control Center is the mission director for this Hubble Space Telescope servicing flight, Randy Brinkley. Randy, good morning.
Good morning, Rob.
First of all, what was your impression of the way the rendezvous and retrieval of Hubble was executed this morning?
Well, I think both the rendezvous and the retrieval could be best described as flawless. Ken Bowersox commented that was working just like in the simulator, and so everybody is extremely pleased. As a data point, we were able to save 140 pounds of prop over what was predicted, so obviously Dick has done a good job giving us back an extra 140 pounds of propellant after the completion of the rendezvous.
Randy, all in all, how do you think the telescope looked after 3.5 years in orbit?
Well, I think as everybody predicted, and you've got I think a comparison shot there if you had switched to, that shows on your left is a computer-generated prediction of what we thought the solar arrays would look like after 3 years on orbit based on the ground telemetry we have, and the picture on your right shows you the actual. So you can see there's a little more bow in the bistem than was originally predicted, but nothing that has surprised anyone. And again, talking with Dennis Eden and Joe Rothenberg and the folks that have looked at this, they still feel that there's a good likelihood that we'll be able to roll up the solar arrays.
Randy, that was my next question. How might the astronauts handle that array during the second spacewalk Sunday night to change out the two solar arrays?
Well, we've certainly spent a great deal of time developing procedures and doing joint integrated simulations of contingencies related to a failed solar array retraction. Our approach will be at the completion of the end of EVA Day 1. The ground will command the solar arrays to be retracted, and hopefully they will be. If their solar arrays, particularly the V2, the one that was bowed as you saw in the picture, does not retract, we'll then try to re-extend it, and we will know before the crew goes to sleep that night at the end of EVA 1 whether or not we will have a normal retraction of the solar arrays, or we will have to implement our contingency procedures, which will be to take the solar array as is. If it fails to retract, stow it on the side and put on a new solar array, and then we will have to jettison that particular solar array. Right now the team is looking at the analysis, but the feeling is from the ESA experts that there's a good likelihood that that solar array will in fact be able to be rolled up. However, we have trained extensively for this contingency. It will not be a surprise, and we're fully capable of dealing with the solar array replacement whether or not we have a retraction of the solar arrays.
And finally, Randy, at this point of the mission, your reaction to the way the flight is progressing?
Well, I'm pleased, and everyone is pleased that things have gone probably better than, or they have gone as planned, but better than anticipated. So far, we've been very fortunate in terms of anomalies, and we've run into nothing that has surprised us or caused us concern in terms of our ability to safely complete the mission objectives.
Thank you, Randy, for joining us today.
Thank you, Rob.
As we said earlier, the capture of the Hubble Space Telescope culminated a busy day of activity for Endeavour's astronauts. The road to reach Hubble was a long one, but the journey proved to be flawless.
Last night, as flight controllers plotted the final phase of the chase to catch the Hubble Space Telescope, the astronauts were awakened for their third day in space.
Hey, good morning, Houston. We're ready to go grab that thing.
I bet you are. We were hoping you'd say that. Good morning to you.
Endeavour slowly steered toward Hubble as Commander Dick Covey and pilot Ken Bowersox fired the shuttle's maneuvering jets several times to move within 41 nautical miles of the telescope, giving the astronauts their first view of the shiny observatory.
Tally-ho on Hubble there, Houston.
Copy that, Covey. We're anxious to hear any words you have to say about what you see.
As Endeavour closed in on Hubble, astronaut Jeff Hoffman used binoculars to examine the telescope and told flight controllers one of Hubble's solar arrays appeared to have warped during its 3.5 years in orbit.
My initial report on 2 straight solar arrays was made about 5 minutes after sunrise, and about 15 minutes ago we started looking again when it came out of the sun's glare, and the right-hand solar array, as we can see it, is one side of it is bent way over. So clearly we have a dynamic situation.
As Endeavour edged to within 35 feet of Hubble, pilot Ken Bowersox told Mission Control the size of the telescope was as impressive as everyone thought it would be.
Endeavour, the Keep Alive monitor is disabled, and you've got to go for capture.
And Houston, it's really big.
Finally, with Hubble's key components turned off, it was time for Commander Dick Covey to make one final maneuver to allow mission specialist Claude Nicollier to extend the shuttle's robot arm toward a grapple fixture near the top of the telescope.
Houston, Endeavour has a firm handshake with Mr. Hubble's telescope.
We copy that, Covey, and there are smiles galore down here.
It's quite a sight.
Nicollier then began a lengthy process to gently lower Hubble onto a berthing platform in the rear of Endeavour's cargo bay. Hubble was finally latched in place, awaiting its overhaul by 2 teams of spacewalking astronauts.
Now that Hubble has been hauled into Endeavour's cargo bay, the focus of attention turns to the 5 planned spacewalks to service the 12.5-ton instrument. The whole point of visiting Hubble in this first of several planned maintenance flights is to improve Hubble's scientific capability.
The Hubble Space Telescope was designed to provide astronomers an unfiltered view of the universe. Unlike ground-based observatories, Hubble has trained its array of scientific instruments on celestial objects for the past 3.5 years outside of the obscuring mask of the Earth's atmosphere. But Hubble has been operating with slightly impaired vision. 2 months after its deployment from the Shuttle Discovery in 1990, engineers were startled to find that Hubble's 94-inch primary mirror had a flaw known as spherical aberration, much like an optometrist grinding perfect lenses for glasses, only to the wrong prescription.
Well, the flaw actually is very tiny. If you think of the mirror as 94-inch curve, a concave mirror, the edges of the mirror have about 2 microns of glass ground off or polished off too much. That is, they're too flat by about 2 microns. That's not a number that most people are familiar with, but if you put it in perspective, 2 microns is about a 50th the width of a human hair.
In spite of the spherical aberration, Hubble has uncovered unprecedented information about the formation of new galaxies, the discovery of new moons around planets, black holes, supernova, and quasars. Hubble has the potential to detect objects 25 times fainter than the dimmest object seen from Earth. If the telescope's primary mirror aberration is solved, the benefit for astronomers around the world could be limitless. Even now, Hubble's scientific finds are extensive.
Been able to make week-long observations of storm patterns on Saturn, of looking at our own nearest galactic neighbor, the Andromeda Galaxy. What surprises can be left in that? But you look at it with a Hubble telescope, and all of a sudden you see it has 2 cores instead of just 1. Incredible things. For me, I think the most exciting thing that I've seen come from the Hubble telescope is the actual view of a black hole, which, just is mind-boggling.
The concept of something so powerful that can look so far into the past and so far out that it tends to show what our place in the universe is. That it tends to give some form of meaning to our existence here on this planet.
Space Telescope brings a promise of learning one heck of a lot more about the universe, seeing further out than we've ever seen before. My belief is that most people do not believe that they're going to uncover lots of answers. They're going to raise new questions. We're going to be exciting and different things that are going to further stimulate our imagination.
Servicing missions to Hubble have been scheduled every 3 years or so during the observatory's planned 15-year lifetime. How much Hubble's vision has been improved won't be known for sure for about 2 months. It will take that long for engineers to complete the alignment and testing of the new optical instruments placed in the telescope, which are designed to bring celestial starlight into sharper focus.
We'll be back on NASA Select Television tonight at 8 p.m. Central Time on Mission Update with a detailed, comprehensive preview of the first Hubble servicing spacewalk. In the meantime, here's a look at the rest of the day's events. Less than an hour from now, Claude Nicollier will park the shuttle's robot arm in an extended position along the side of Endeavour's cargo bay. It will be used tonight and the next 4 nights after that to ferry a spacewalking astronaut around the payload bay during the various servicing tasks. Just before 7:30 this morning, the 4 spacewalkers, Musgrave, Hoffman, Thornton, and Akers, will hold a meeting to discuss their strategy for that first servicing spacewalk. At 9:30 a.m., we'll conduct our mission status briefing to discuss Hubble's retrieval and plans for the first spacewalk tonight. Within minutes of that, engineers at the Goddard Space Flight Center will send computer commands to warm up Hubble's soon-to-be-sacrificed high-speed photometer and the telescope's scientific instrument data processing system as a way to preserve the health of these instruments following Hubble's retrieval. At 9:57 a.m. Central Time, with Hubble safely locked down in their ship's cargo bay, Endeavour's astronauts will begin an 8-hour sleep period. 1 hour later, we'll show all of the video highlights of today's retrieval activities on our daily Flight Day Highlights package on NASA Select Television. The astronauts will be awakened tonight at 5:57 p.m. to begin their 4th day in space. 1 hour before we go to the Goddard Space Flight Center for a look at the work engineers are involved in at the Space Telescope Operations Control Center. At about 8:30 this evening, Story Musgrave and Jeff Hoffman will begin to climb into their bulky spacesuits for the first of 5 planned servicing spacewalks. They'll be assisted by their colleagues, Kathy Thornton and Tom Akers. An hour and a half later, all suited up in the shuttle's airlock, Musgrave and Hoffman will begin to breathe pure oxygen to cleanse the nitrogen from their bloodstreams. At 10:47 p.m. Central Time tonight, after depressurizing the airlock, Musgrave and Hoffman will put their spacesuits on battery power and will open Endeavour's airlock hatch to begin the first of 5 spacewalks to refurbish the Hubble Space Telescope. The first spacewalk will involve the replacement of 2 gyroscope packages, 2 companion electrical units, a series of fuse plugs, and the preparation of the new solar arrays for their installation on Hubble early Monday. One thing to keep in mind, the astronauts could elect to start their spacewalking preparations and the spacewalk itself up to an hour early to add more margin to their servicing task timeline. We won't know the exact time of the start of the first spacewalk until later tonight. Well, that brings us to the Mission Control Center, where the retrieval of the Hubble Space Telescope was orchestrated a few hours ago, and where mission commentator Kyle Herring is to fill us in on the latest on Endeavour's flight. Kyle, good morning.
Well, good morning, Rob. As everyone can imagine, there was quite a bit of excitement here this morning, especially at the point when the telescope was actually captured by the robot arm. This team, as you can imagine, has gone through an extensive amount of planning, training for this moment, and to actually finally see the telescope after 3.5 years rather than seeing it during simulations means a great deal to this team, and there was quite a bit of excitement. You heard the hand clapping when the telescope was captured. Having said that, though, this team is also very professional, and it was amazing to see how quickly everybody got back to business, how quickly we changed handover to change the flight control teams here at the capture, and immediately got down to business. Lead Flight Director Milt Heflin immediately said, well, that's one step done, let's go on to the next. So it's, while everybody was excited and amazed to finally see the telescope after 3.5 years, everybody is extremely professional and immediately got back down to business. So, and that's where we are now. We're continuing to get some television, obviously, of the various components of the telescope, and we're still moving through the timeline just as pre-planned. So everything is going very well at this point, and everybody's extremely happy.
Kyle, what kind of discussions are taking place among the flight controllers about that kinked solar array and its bistem?
Well, the discussions that are ongoing right now are primarily with our payload officer, Jeff Hanley, and he's coordinating with the ESA folks and also with the HST project folks. And they're off looking at that, but as you heard Randy Brinkley mention, they think that it's going to be fine. They think that it ought to be able to roll up just as it did when it was deployed on the secondary deploy mechanism 3.5 years ago, although there are plans in place in case it doesn't. They are off working at that. They're having some technical discussions right now to evaluate it, and they're getting a lot of downlink television that the crew's sending us. So we'll be looking at that very closely, but right now, based on what we've seen, we are planning for the first EVA, just as it was planned pre-flight, to do the rate sensor unit change out, the electronic control unit change out, and also the fuse plugs, prepare the solar array carrier, and then press on to the second day with the press on with rolling up the solar arrays at the end of the first EVA that begins tonight. So everything is still staying right on schedule for our first EVA.
Thank you, Kyle, for that report.
Okay.
A reminder, our mission status briefing is coming up on NASA Select Television at 9:30 a.m. Central Time. Coverage of Endeavour's mission continues around the clock even while the astronauts are asleep. And we'll be back tonight at 8 p.m. Central Time with 2 astronauts preparing to walk in space to begin the servicing of the Hubble Space Telescope with our next edition of Mission Update.
It looks to us like the parts of the bistem are split apart right here in the view you're seeing now.
Okay.
This is Mission Control Houston. These are views from a camcorder being shot through the aft flight deck windows of the solar arrays on the Hubble Space Telescope, which is locked in place on the flight support system in the aft portion or the back portion of the payload bay.
Endeavour Houston.
Go ahead, Greg.
KT, we're interested in your observation on how much twist there is in the bi-stem, and we would appreciate a view of the ends of the solar arrays at the compensator rails.
Looks to us like it twists about 90 degrees, and I'll try to get you pictures of the ends. None of the compensator rails are bottomed out. They're all somewhere mid-range.
None of them are. Okay. I thought we had been told earlier that the upper one was bottomed out. Well, we'd like to take a view of that if we could. And your 90-degree assessment jives with what I'm seeing down here.
These arrays are very dynamic. They'll change from minute to minute. Now I'm looking at them. I do see one of the upper ones bottomed out on the left hand, the minus V2. But I'll try to get you a view of those.
Okay, well, that's a good piece of data, too, that what you're telling us is going to change over time. Thank you for zooming out.
We thought you should enjoy some SAS symptoms as well.
Been there, done that.
How do I give you this view while we're setting up?
Say again, Claude?
We'll just give you another view while we're setting up.
Okay. That's a great idea. Thanks. Endeavour Houston on your VTR playback block.
Go ahead, Houston.
Claude, in the flight plan, there's a call out at the block is scheduled at about 3 hours MET for VTR playback. However, the times called out on the block are incorrect. That should be 2 hours, 59 minutes to 3 hours, 31 minutes.
Roger that. I figured that out.
I figured you did. And be advised that there is a possible KU gimbal flip around 3 hours, 17 minutes, so we'll have a little bit of dropout around that time.
Houston Endeavour. I think we'll have to wait till sunrise to show you the compensator rails.
Fair enough. Endeavour Houston, we're going to be off the nose.
Roger.
Go ahead, Story.
Yeah, could you verify that we have 4 in-suit drink bags on board? 1 for each person.
We will check.
We've done the best we can. We've only found 2. 1 for EV1 and 1 for EV2. Excuse me, 1 for EV2 and 1 for EV3. The 2 big ones we can't find.
Okay, Story, we understand. We'll investigate. Go ahead, Story.
Yeah, after filling EV2 drink bag, it continued to leak out of the hole where you fill it, where you insert the needle. It wouldn't stop. And what we did was push a food drink straw into the hole, bent it back on itself, taped the bend, and then taped it to the drink bag with great tape. And the clamp, of course, is on the straw.
Okay, Story.
If you need more elaboration, let me know.
No, we understand. I'm just curious how you're going to open that thing with your teeth.
That's the fill end, of course.
That's right. We knew that. Incidentally, Story,
Sorry.
we are looking at tracking down drink bags for EMUs 1 and 4. The preliminary assessment is that should have all been stowed together. All 4 drink bags should have been stowed together. And the drink bags for EMUs 1 and 4 are the larger size. So if you didn't see them there with the other 2, we're going to try to track down and find out where they might have ended up.
Yeah, looking at the paperwork, expected 2 in the airline storage bag and 2 by themselves, volume H.
We're being told that they should have all been in the airlock stowage bag, 2 in each end.
Okay, we only found 2.
Okay, we copy that.
And it wouldn't have mattered except for the leak.
We understand. Endeavour Houston, Story, your drink bag leak workaround sounds fine to us. We understand that was done in 57 and that it worked fine.
Okay, yeah, we like it. We're going to watch it a bunch more. We'll leave it overnight.
Endeavour Houston with a couple of miscellaneous items for you.
What kind of miscellaneous crew person do you want?
I'll take anyone that you want to offer up.
Orbit or EVA?
I've got a little bit of both, Story. That's why I didn't categorize it any more clearly. Since you're listening up first, I'll talk to you. The one comment we have from the EV folks down here is we would like you to wrap a towel around your drink bag leak stop thing just to make sure we don't get any free water in the cabin. Also, for the telescope folks, be advised that we are showing a state of charge of 498 amp hours. As a result, no additional battery charging will be required until after the new solar arrays are installed. This means that the maneuver that's called out at 5 hours and 15 minutes in the flight plan can be deleted. That was intended for additional battery charge and is not required. One last item for an orbiter.
Okay, Greg, a copy. Delete the 515 maneuver. Okay, and wrap it down on the drink bags for no free water in the cabin, and the battery's got a state of charge of 498, so no charging until after they got the new arrays.
Roger that, and it's a good copy by Covey on the maneuver. And one other item for Covey and SOX. Evidently earlier today there was a call made about L4L. That jet is okay. It turned out that we were in a very low data sample rate, so Prop did not see the jet fire. It did fire, it's fine, and there's no cause for concern with that one. The other one, L2 uniform, did indeed fail.
Okay, we copy, and that was our understanding also.
Okay, just want to make sure we're clear on that, and that's all I've got for you right now. We're still looking at the state of the BISTEM. There's a meeting going on right now, and I expect to have some words for you on any potential impacts.
Okay.
This is Mission Control Houston here in the flight control room. The current flight control team has been on console since about 2 o'clock. Took handover from the previous team at the point at which the Hubble Space Telescope was captured by the shuttle's robot arm. Since that time, of course, Hubble has been carefully placed in the payload bay and is ready for the spacewalking activities scheduled to begin later tonight. In association with that, there was some discussion from the orbiter by Story Musgrave looking for drink bags. Those are bags that are used in the spacewalks, during the spacewalks, by the crew members. Those are drink bags that are mounted on the suits that the crew members can reach from inside the helmet. Also, there's been some extensive surveys done with the shuttle's robot arm and other various cameras that are located in the payload bay of the orbiter, looking at the telescope from various angles. It appears to be in good shape and ready to support the spacewalks. The only out of normal issue that was seen was the kink in the outer bistem on one of the solar arrays that showed the solar array twisted. The crew's reporting that the bistem appears to be twisted and kinked about 90 degrees or so. Much of what was seen was thought pre-flight to be a potential problem, and was certainly not a surprise to the team. In fact, there were many various scenarios put into place, contingency plans as they're called, for just such an event. However, the telescope community, in conjunction with the ESA folks, the European Space Agency folks, preliminarily report that it doesn't appear that should impact rolling the solar arrays in on the secondary deploy mechanisms, which is scheduled to be done at the conclusion of the first spacewalk. However, they are forming a technical team to look at that a little bit more extensively before we get to the spacewalk. But there are several contingency plans that have been put into place in the event that it does not roll in any case. In the meantime, several commanding sequences are continuing to be sent from the Space Telescope Operations Control Center, which is located at the Goddard Space Flight Center in Greenbelt, Maryland. The latest command sequence that's scheduled is numbered number 34, and that is to turn on the fine guidance electronics. The command plan, as it's called, is a series of command sequences that are conducted throughout the mission associated with the telescope itself, and all of these command sequences for the most part are sent from the Space Telescope Operations Control Center. The onboard batteries for the telescope have been fully charged. Once the telescope was berthed on the flight support system, an electrical umbilical was mated to the telescope, and the telescope was then pointed and the batteries charged to ensure that they have a good charge. And the report is that they are fully charged now and should be able to support electrical power to the telescope until the conclusion of the second spacewalk, which is the one scheduled to replace the solar arrays.
Endeavour Houston, we are about 30 seconds from handover.
Okay, Greg.
Endeavour Houston, we are with you on the east. Go ahead.
Yeah, Greg, I just was checking to see if you guys wanted to do a little bit of the video playback now. We've scraped together 5 or 10 minutes. It's going to take us longer to find much more.
We're talking about it, SOX. Stand by. Endeavour Houston, SOX, we'd still be interested in any video that you may have of the compensator rails, if you have anything there, and anything associated with the grapple, since we didn't get to see that real time. But we'll be happy to take whatever you've got.
Okay, we have a real time of the grapple, and the compensator rails, I'm not sure we're going to be able to find that real quick.
Okay, that's fine.
We could show that real time to you if you'd like to look at some of it. We've got the camera, Hubble camera on the arrays now.
And we see that. Do we need anything? SOX, we'll just take your VTR playback.
Okay, I guess you guys need to go async and let us know when you're ready.
We are all set, SOX. Press on.
Okay.
Pilot Ken Bowersox aboard Endeavour discussing views of the Hubble Space Telescope.
End effector camera view of the final phase of the rendezvous.
Okay, SOX, we are getting that now.
Okay.
once Commander Dick Covey moves the shuttle to within about 30 feet or so of the telescope, mission specialist Claude Nicollier, operating the robot arm, was able to use a camera on the end of the robot arm called the end effector camera to help in positioning or guiding the robot arm over one of the two grapple fixtures on the telescope. Above the circular grapple fixture is a guidance bar that is used by the astronaut to help in fine-tuning the end effector over the grapple fixture prior to actual capture. There's a series of snares inside the robot arm end effector that once it's latched onto the grapple fixture, the snares lock into place, providing a rigid capture of the spacecraft.
See, it got dark right in the middle of the movement in the grapple position.
We can see that, Sykes.
Caused some excitement.
Again, using a guidance pin on the top of the grapple fixture, Claude Nicollier was able to...
I'm going to stop this one and switch over to an A-camera view about the same thing.
Okay.
Again, Nicollier was able to capture the Hubble Space Telescope using the guidance pin on top of the grapple fixture. Again, the actual capture of the telescope requires some precision flying by the commander, in this case Dick Covey, to maneuver the shuttle into position to within about 35 feet or so of the telescope. At that point, Claude Nicollier, operating the robot arm, can maneuver the arm into place to capture the spacecraft by attaching the end of the arm to one of the two grapple fixtures on the telescope.
Houston Endeavour, we're ready to begin the wastewater dump. You want to do step 1?
Okay, Covey, we're going to uplink some Timbus in preparation for that waste dump, and you can expect to get a Spec 66 waste message. Also be advised that the dump should last about an hour and 5 minutes.
Okay, I copy.
Endeavour Houston, we lost the TV. We're in blockage. But what we saw was great. Thanks very much.
Okay, great.
Endeavour Houston for Claude. We see you putting the arm away for the night. We would like you to leave the elbow camera selected if you would, so we can get some video overnight if we need it.
Roger, Craig, we'll do that.
Thanks. Endeavour Houston, we're a minute and a half to LOS. We'll pick you back up on the west. 0403 will be ready for the PMC 0405.
Roger, Houston.
This is Mission Control Houston. Here in the flight control room, the Orbit 2 team under direction of lead flight director Milt Heflin will be wrapping up its shift about 10 o'clock this morning. Beginning at 9 o'clock this morning, a handover to the planning team will take place. That typically lasts for about an hour or so. Activities are pretty much winding down on the shift as the crew is officially in its pre-sleep period prior to going to sleep in about 2 hours. Endeavour, on its 33rd orbit of the mission, has just moved out of range of our communications satellite network. The orbiter will be out of contact for about 2.5 minutes or so. The orbiter is moving from daylight into darkness as it flies high above the Indian Ocean in a payload bay to Earth attitude with the nose of the orbiter pointed toward the south. This is the attitude that the orbiter will remain in throughout the crew's 8-hour sleep period. During the last hour and a half or so, primarily here in the flight control room and in the back rooms, there's been some discussion on activities associated with the first EVA and also with our management of the solar arrays and how we're going to, or how we plan on dealing with the solar arrays in the wake of the bent bistem on the plus V2 solar array that's on the right-hand side of the telescope looking from the aft flight deck windows of the orbiter. And the Hubble Space Telescope program management team has been off having a meeting, and that meeting has concluded, and the words and the plan pretty much remain as pre-flight planned. The first EVA will go on as planned with change out of 2 of the 3 rate sensor units, 2 of 3 electronic control units that interface with those rate sensor units, and also change out of some of the fuse plugs on the telescope, up to 8 of those fuse plugs. The plan that is being put into place now is no different than pre-flight scheduled for the first spacewalk. At the conclusion of the first spacewalk, the solar arrays, the plan is to roll the solar arrays up on the secondary deploy mechanisms. That is the window shade type devices that roll the solar arrays in and out. There is going to be a little bit of tweaking to that, the roll-up plan for the solar arrays, and that plan is being put together and is scheduled to be voiced up to the crew in just a few minutes. As planned in the flight plan, there's typically a next day's spacewalk review plan that's supposed to be uplinked to the crew prior to the crew going to bed, and that in fact is being put together, and astronaut Greg Harbaugh here in Mission Control will be voicing that plan up to the crew when we get the communications link back and after the routine daily private medical conference is concluded here shortly. Again, all activities have gone very smoothly today with the retrieval, the rendezvous, and retrieval of the telescope. It's gone almost exactly as planned. The retrieval and capture of the Space Telescope occurred at 2:48 a.m. Central Time, and that was as planned as the orbiter moved into sunset high above the southwest Pacific Ocean, just to the northeast of Australia. That occurred with Endeavour somewhere about 29.5 orbits into its mission, and the capture actually took place as Endeavour was traveling through about 800 miles into its voyage on this mission.
Endeavour Houston, we're with you on the west.
Roger, Houston, and we're doing antenna cable positioning at this time.
We copy, and we're setting up for the PMC here momentarily.
At the 800,000 mile point in the Endeavour mission.
I'm working configured for PMC.
The telescope was then carefully lowered into the payload bay by Claude Nicollier operating the robot arm, and latched into place on the flight support system, the circular flight support system in the back of the payload bay that rotates and tilts, presenting the various work sites in the forward position for the astronauts doing the 5 scheduled spacewalks. The electrical umbilical was attached to the telescope, and that was done as planned. The telescope batteries were charged thoroughly. And those batteries again were charged fully, and they don't expect to be required or needing to be charged again until the solar arrays have been changed out, scheduled for the second spacewalk. Various commands from the Telescope Institute, the Space Telescope Operations Control Center at the Goddard Space Flight Center, have been sent throughout the day to the telescope, protecting heaters, turning heaters on to various instruments on the telescope, managing all of the science instruments, commanding latches to be closed or opened in the case of the high-gain antennas on the telescope. Those latches are in place, the high-gain antennas are locked in place, and while one of them is not fully latched in place, it appears to be secured enough, and the telescope community is off looking at whether that's latched properly enough to support the reboost efforts after all the spacewalks have been completed, and that is an open discussion that has not yet been decided. Throughout the morning, various camera angles have been seen of the telescope in the payload bay of the orbiter. This one of the cameras mounted on the robot arm. This is on the elbow joint of the arm. The work site on the telescope pointing forward now is the aft shroud area where the rate sensor units are located behind the fixed head star trackers in the lower portion of the telescope, and just above that is the location for the radial instrument, the wide field and planetary camera, which will be removed, and a new wide field planetary camera installed, scheduled for the third spacewalk of the 5 planned on the mission. Again, all activities have gone very smoothly associated with the rendezvous and berthing of the telescope in the payload bay, and all appears to be in good shape with the orbiter. There have been no issues and no discussions in the room throughout this shift relating to any issues with Endeavour. Which basically leads us to the flight plan, which shows the first spacewalk beginning tonight somewhere around 11 o'clock. However, there is an option that the crew can go out early if they get ready. The first spacewalk astronauts scheduled for that spacewalk are Jeff Hoffman and Story Musgrave. Endeavour's currently moving from daylight into darkness as it moves from southwest to northeast across the Indian Ocean to the northwest of Australia, approaching the equator to begin the 34th orbit of the mission.
Okay. Endeavour Houston, we are back with you, and I've got the summary of next day EVA updates when you're ready to copy.
Stand by. Okay, Greg, go ahead.
Okay, I've got a number of bullets for you. Let me see if I can run through them quickly and effectively here. First of all, we've had a fair amount of discussion on the solar array bi-stem, as you might imagine. The plan for tomorrow, after the EVA is complete, is to retract the minus V2 first, and then the plus V2. That is opposite of the way we had planned to do this previously, but it is consistent with our previously baseline philosophy. We think you understand that approach, and I'll be happy to discuss that further with you if you'd like. We do not plan to ask the EV crew members to stay outside and watch the retraction. We will stick with our normal plan there. We are looking at every option associated with maximizing the probability of good retraction of both arrays. That may include a new attitude as one of a couple of ideas that have come up. We're going to let the planning team look at that overnight, and so don't be surprised if there's a change along that line tomorrow morning. What we are proposing for EVA Day 2 is we change out the plus V2 first, then the minus V2 second. And we think, again, that this is fairly consistent with the previously understood philosophy, given a so-called better and not as good array, if you will. We would like you to think about that and give us your thoughts. We're soliciting your inputs on that sequence. Keep in mind...
okay, let us counsel here and think about it.
Okay, we'll let you think about that a second. I've got a couple other notes. The HST project is confident that the bi-stems will be able to retract, and I'd refer you to the pre-flight training and bi-stem demonstrations that you all were involved with, where you twisted it and bent it and everything, and it still worked. The easy task priorities, should we have the opportunity tomorrow, are number 1, solar array easy tasks, number 2, whiff pick, with the exception of the PFR setup. And finally, we should have an answer for you shortly, hopefully, on your drink bag configuration, where those last 2 bags disappeared to. And we will stand by for your comments on the proposal for EVA Day 2.
Okay, we'll get right back to you.
Endeavour.
Go ahead, Endeavour.
Yeah, we've talked over the plan, and we don't have any problems with that. Sounds like a good plan. Retract minus V2 and then plus V2, and we'll be looking for a possible new attitude for the plus V2. Day 2 plan, we'll go plus V2 first, followed by minus V2 change out. Any easy task, we'll start with solar arrays on tomorrow, and then whiff pick if we get to them, accept the PFR, and we'll be waiting for words on the in-suit drink bag.
Okay, Tom, sounds good to us. We appreciate your thinking about it, and we'll get your words on the drink bag as soon as we can.
Okay, thanks.
This is Mission Control Houston as Endeavour makes its way across the Pacific Ocean, approaching the Hawaiian Islands from the northwest. This is the 34th orbit of the mission. As has been typical every day, with the crew approaching its sleep period, Lead Flight Director Milt Heflin checking with all of the flight controllers here in the flight control room to get any final messages that need to get up to the crew before we say goodnight. The crew's sleep period officially begins in about an hour and a half. Just a short while ago, astronaut Greg Harbaugh here in Mission Control was basically giving the crew the plan and getting their thoughts on the plan for tomorrow and for the or for later tonight's start of EVA number 1 and for the second EVA. And basically the plans are no different as pre-flight scheduled for the first spacewalk. The only difference is the order in which the solar arrays will be retracted at the conclusion of the first EVA. And the crew had no problem with that, as well as reversing the order in which the two solar arrays will be changed out on the second spacewalk. Since the change out of the solar arrays is identical, switching the order in which the arrays are changed doesn't matter in terms of the work schedule for the astronauts who will do the spacewalk. The spacewalk to change out the solar arrays is scheduled for EVA number 2, and that is scheduled to be conducted by Kathy Thornton and Tom Akers.
Houston, Endeavour wastewater dumps complete and ready for step 8. If y'all can tambu up the limits.
That is in work, Covey. That is complete, Covey.
Thanks. Endeavour.
Endeavour Houston, go ahead.
Hey, Greg, I was wondering if we're going to do a star align tonight.
Negative. And I am just about to come to you with our closing comments for the day. I'll have that for you in a minute or two here.
Okay.
Endeavour Houston with last call.
Go ahead, Houston.
Covey, we have sent your sleep vector up. That is already on board and verified good. We would like the RMS joint switch to taking to crit temp, please. The HST folks have verified that the high gain antennas are adequately latched for reboost, so that is no longer a concern. We have pursued the drink bag issue and will continue to do so overnight. We have not come to a satisfactory conclusion as to why the drawings show one thing and you're discovering something else on board. However, it seems prudent to us for you to plan on using the two that you've got for the EVA tomorrow, and we will continue to work that. Finally, I have your pre-sleep.
Greg, we did turn the vehicle upside down. We went back to volume D, back to volume H. We opened up every suit. We've done all we can, and now we've got two on board, we think.
Okay, Story, we understand.
And they'll work fine for all EVAs.
Okay, just treat them tenderly, I guess. And as Milt says, you've got 4 campers and 2 canteens, so I guess you can act that. And finally, I have your pre-sleep cryo config when you're ready to copy.
Okay, Greg, we got the joint to crit temp, and we'll copy everything else, and SOX is standing by for the valve reconfig.
Okay, panel R1, cryo O2 and H2, tank 1, heaters Alpha and Bravo, all 4 switches to auto. Cryo O2 and H2, tank 2, heaters Alpha and Bravo, 4 switches to off, OFF. Cryo O2 and H2, manifold valve, tank 1, 2 switches to close, talk-back close. That is it. Again, great day's work today. And I'm sure you're as excited, if not more excited than we are, see you guys go do some useful work tomorrow. So good night, sleep well, and we'll talk to you in the morning.
Okay, Greg, we copied the config, and yeah, we got a much better view than you do right now as I sit here looking back out the overhead and aft windows at a magnificent telescope drifting over the Atlantic Ocean here. This is fantastic.
Well, at least you're not rubbing it in.
Hey, Greg, this is Fox. One more thing. I hope you'll have the results of the Army-Navy game for us in the morning mail. I'm going to wear my Navy sweatshirt to sleep tonight. Maybe that'll bring some luck.
Okay, well, we'll do our best to get that to you, Sox. And at the earliest opportunity, we'll make sure we do that.
And Greg, you can pass on to the IFM guys that we buttoned L17 panel back up.
Okay, Tom, thanks very much. That was an open question that we were kind of holding off asking you. That helps. Thanks a lot.
Talk to you tomorrow.
And Endeavour, check your cryo O2 and H2 manifold valve, tank 1, 2 switches to close.
Yeah, we just got him, Greg. Thanks
okay,
a lot.
Thanks a lot.
And beat Army.
Yeah. Good night.